Welcome to Texas Highway Products Tutorial 126. This tutorial is about conditional double cycling. In MaxTime, our Intellite controller software, we have an application where this can be very handy, where you have very little or minor traffic on the side street and you want to maximize the flow on the main street. So this is how we'll get started. MaxTime is a very simple and easy way to double cycle phases. Basically, you use a restricting where a phase isn't serviced during a cycle, so all the other phases are double cycled. So we will simply go to phase option, scroll down, and we can find a phase to be serviced every even cycle and a phase to be serviced every odd cycle. So one cycle around, phase 4 will run, it will skip phase 8. The next cycle will skip phase 4 and run phase 8, but all the other phases, 1 and 2, 5 and 6, will be double cycle. But sometimes we want to have a little bit more conditional logic, and that's what this tutorial. So what we want is an application is a side street that has very little traffic. In the main street, we want to maximize the flow. Therefore, what we want to do is set up a primary phase and a secondary phase. So when the controller is double cycling, it runs 1 and 5, 2 and 6, it will get to an interval where the primary phase is 4. If there's no call on 4, because it's a minor movement, very little traffic, it can go from 4 to 8. So it'll either run 4 or 8 during interval 3. And the same thing happens at interval 6, only we switch the service phases around. So when we get to interval 6, it runs 8. If there's no call on 8, it runs 4. But it can only run one of the two phases in each of these intervals. So our conditional logic is conditioned by the vehicle demand. So we have our sequence laid out where we're going to double cycle 1 and 5 and 2 and 6. So we talk a little bit about the side street. So if we got cars on both 4 and 8, 4 will be serviced at interval 3 and 8 will be serviced during interval 6. So when it starts the interval, when it goes to like interval 3, it can run either 4 or 8. So if there's no demand on 4 and 8 starts, and you get a call coming in late on 4, that car has to wait a cycle to be serviced. Or if it gets to interval 6 and the cars have been cleared out of 8, 4 can come up during interval 6. So it could be either a full cycle or a half cycle for late arrivals. So that's kind of important. If you had one side that was really heavy, you could run 4 in interval 3 and 4 in interval 6 and double cycle the heavy movement as long as there's no demand on the other side of the side street. So you have three possible ways of looking at this. If we have heavy demand on 4 and 8, the cars on 4 and 8 will be serviced once per cycle at their appropriate intervals. If it's lopsided on one side versus the other, you could actually double cycle that one side. Or if you don't have any cars at all on 4 and 8, it will just continue to extend 2 and 6 and 1 and 5 based off of the demand within the chord cycle. So this gives us some flexibility for the really minor movements going. Sorry for the dead spot, but anyway, first thing you want to do is set up some overlaps, and this is how the sequence really works. So it's going to go 1 and 5, 2 and 6, and it's going to run either 4 or 8. Then it's going to run 11 or 15, which is also the phase 1 and phase 5 movement. Then we'll move on to 12 and 16, which is the 2 and 6 movement. And then the 18 versus 14 is phase 8 first and then 14. So I have a little graphic laid out on the side of how we're going to configure this, and we'll go into MaxTime and set all the appropriate fields and settings to make this happen. There's not a lot. It just may look a little complicated at the start, but we should have a good time. The first thing we want to do is go back into phase options and uncheck the even and odd cycle settings that we just put in. We don't want to do it that way. Those will just interfere with us. So we want to get back to our standard data. I've started off with an 8-phase quad database, and always the first step is to tag your database. So I went in here to administration unit information. I gave it a name, an agency, and a little description. So when I hit save, I can always know what I'm working on. So after I've tagged the database, the next step is to go and check my cabinet type. So I go to Controller, Advanced I/O, Cabinet Configuration, I/O Modules. I just want to check to see what it is. It can be in any cabinet, but you don't want to do all your programming and find out you're in the wrong cabinet. So right now I got a TS1 cabinet. The first real programming is in the sequence. So if I looked at my sequence, I don't have a 3 or 7 or a 4 and 8. So what I'm going to do is do a split phase. So ordinarily it'd be 1 and 5, 2 and 6, cross the barrier, run 4, and run 8. However, because I have to make this a little bit more exotic, I need a phase 9 as a split holder. So I'll run the time for the split in 9 to make whether it 4 is first or 8 to balance my coordination cycle. And then at the end, I need to add in the other phases, which are 11 and 12, and then 18 and 14 is the reverse of 4 and 8. It's going to be 8 and 14. Then in the appropriate site ring 2, I have to go in and I have to add in 5 and 6, which is 15 and 16, phase 10, to do the same uh, split adjustment so I can have a proper cycle length. So this is really the sequence. So we want to, looks just like the previous slide, but this is probably the most important. The next step is to go into phase configuration and set up my startup phases and do my descriptions. So I want to start up in 2 and 6 green, no walk, so I drop those down. It's important that I turn the other phases on. So you'll see a lot of phases here is phase not on. That just means they're not timing on startup. The nones, like 3 and 7 and 13 and so on, are just not being used at all. Notice the ring number comes in automatically from the sequence. And then we go over and look at the sequence. So phase 1 is northbound left turn, and phase 11 is northbound left turn. So 1 and 11 will be an overlap. And the same for 5 and 15. Once this is set up, we're good. We'll then go into phase options and enable our phases. So up here we'll have all the phases we're using enabled. We also set them for non-locking memory, so we don't have any of those. But we spend a little extra time and we dual entry the through movements. And particularly 4 and 8, we want to pull up that other phase, that 9 and 10, so when it's in coordination, that phase is really my timing phase to handle the split. So I simply went into all the even phases and made them dual entry phases. And the next step will be, of course, our phase times. One of the quick little tricks is to go into the front panel emulator. I'm just going to make it a little bit bigger so you can see it. And go to 2 for phases, and then I can go to 4 for phase time copy. So I can copy 1 to 11, 2 to 12, so on and so forth, to get these upper phases in the second half of the ring, so I don't have to enter data times in. It's just a shortcut. The next step is to set up the detectors. How are the detectors going to call these phases? So we go to controller, we go to vehicle detector parameters, and you notice that the detector is calling both the phase 1 and phase 11. So we want to, whenever the call comes in, wherever is in a cycle, whatever phase is coming up next will be serviced. And I also defined a detector for phase 9 and phase 10, so I can do some detector switching when we're in 4 or 8. So notice we have all the pairs down through 1 to 11, 2 to 12, and so on. After the detectors, we have to go into the overlaps and set up our overlaps. So the overlaps are real simple. We just make them normal overlaps, and we have included phases of the phase pairs. So 8 and 18, 1 and 11, so on and so forth. I kept the We have to go into, now that we got our overlaps set up, we have to go in and set them on the load switches so they come out in the right place. We don't have to rewire the cabinet. So we'll go to Advanced I/O, Channels, Channel Configuration, and we've basically changed the control type from a vehicle phase to an overlap. So load switch 1 is now overlap 1, which both phase 1 and 11 come out on 1. On overlap 4 is assigned to load switch 4, and so on and so forth. There's two sections of user logic that we need to enter. The first section is the backup prevention. So when we're in 4, we don't want to back up to 8. If we're in 8, we don't want to back up to 4. And the same with 14 and 18. So the first 4 lines of the user logic, oops, sorry about that, is basically omit the phase if the other phase is coming up next or is on. So if we're already committed to go into phase 8 or phase 8 is on, omit 4. So this is just simple no backup logic. And then we will go on and look at the detector assignments. The second part of this user program has to do with detector switching. So if we look at this line, it says vehicle detector 9 is equal to vehicle detector input 4 if phase 4 is on. So when phase 4 is on, we take its detectors and we map it to phase 9. So phase 9 is our timer split. So we can have a bigger value for 9 because we can fit 8 and 9 for the split of phase 9. I mean, 4 and 8 split fits for the phase 9. We'll do this in coordination. And then the next line is we're going to switch it if phase 8's on. So we take the phase 8 detectors on that side of the street and switch it to phase 9. And then we do the same thing for phase 10, the second half of the cycle. We take the phase 4 detector and we switch it to 10, or the phase 8 detector to switch it to 10, depending on what phase is timing. So if it's in phase 14, we take phase 4 detectors and switch them over. The last and final step of this is coordination. So we go into coordination and we go into coordination parameters and we can run auto, time of day, system, or whatever. But I'm just going to run pattern 1 for test purposes and hit apply. Then I go into my parameters on my patterns. I got a 90-second cycle, a 10-second offset. Notice that I'm using split 1 and split 2. So all the programming information is really down on the splits in 1 and 2. So we'll go down to splits. And here's where it goes into the logic a little bit. So we look at phase 4 split, and I just have a 10-second split, just an example. And on phase 8, I have a 10-second split. But my timer split is 20. So by passing the phase 4 detectors to phase 9, I get up to a 20-second split, or vice versa. If 8's on, I get up to a 20. If we look at the second half of the cycle, it's the same thing. We look at 14, I got 10 seconds. 18, I have 10 seconds. So I take these two together, and I make that the split on 10. So my 10 is actually going to give me the time I'm going to have on the side street, okay? That's all there is to it, and I just want to thank you for watching this tutorial with me. I hope you found it interesting. I thought it was kind of a fun exercise. I'm sure there's other ones out there that we could do. If you got any examples, please let me know. There's a lot of power in this software and a lot of ways to skin the cat. So happy programming. Bye.